Alright, now we're going to do a lesson on trig ratios, and we'll start with a circle. So there's a circle that you are familiar with, and then I'm going to extend a line segment that it just intersects with a circle, and instead of calling this radius 1, I'm going to call it radius r, because it could be 1 or it could be anything. And now I'm going to drop a perpendicular from that point down to the x-axis. So I have created a triangle there. And before I go any further, I'm just going to refresh your memory that the coordinates of this point here, recall, it's the cosine of x if x is that arc length, and the sine of x. So that means that this distance here is the cosine, and then this distance here, that's the y value, that is the sine. And of course all of this is just valid if and only if r equals 1. Now let's take that triangle out of the circle and let's blow it up here a little bit. And it's a right triangle. There we go. And this is the x-coordinate, this was the y-coordinate, and this is r. So now we're going to define the trig ratios, and let's start with the cosine. So the cosine of an angle, and we're going to call this one theta. There's your theta right there, okay? And remember, if r is 1, and theta would then be the arc length in radians. But theta could be radians or it could be degrees, it doesn't really matter. So the cosine of theta, all these are going to be in reference to theta. Well, that's the x-coordinate, and if the x-coordinate were, if this was a unit circle, that r would be 1, and we can divide that by r, and so that's because r is not 1 in this circle. It could be 1 but doesn't have to be 1. So we can divide that by r, and that's the definition of the cosine of theta. Likewise, the sine of theta, the ratio of that is y over r. And let's skip over here and say the tangent. So you know the tangent of theta, well, you know that's the sine of theta over the cosine of theta, and you've got x over r divided by y over r. And if I were to multiply those out, of course you see that your r's cancel, and you are left with x over r. And then the cotangent, well, that's 1 over the tangent. So you could just take the reciprocal of the tangent, and if you wanted to, you could do the cotangent is the cosine of theta over the sine of theta, and you still get the same thing. You get r over x, and then here at the top let's squeeze in secant. Secant, you will recall, is the reciprocal of the cosine, so that's going to be 1 over the cosine, or 1 over x over r, which is r over x, and cosecant. Where are we going to squeeze the cosecant in? Get rid of this. And the cosecant of theta is doing 1 over the sine, just like we did for the secant. You end up with r over y. These are what is called the trig ratios. Now let me do an example with you and show you how this works. Alright, so I've got a triangle, and it's a right triangle. Okay, there's the right triangle. Here's angle theta. The radius is 3. I'm sorry, the radius is r. This side of the triangle is 3. This side of the triangle is 7. And we want to find all 6 trig ratios. So we first need to find r, because you can't do anything without r. And this looks, you will recall the Pythagorean Theorem, a squared plus b squared equals c squared. And I could just simply say this is the same as x squared plus b squared equals r squared. Same thing, just different variables. Oops, not r, y. There we go. And so I'm going to use my values from my triangle. Let's move over here. 7 squared plus 3 squared equals r squared. So that's 49 plus 9 equals r squared. And 49 plus 9 is 58. So we have to square root that. So r, let's go ahead and make it up here. R is the square root of 58. Alright, let's first start with our cosine. So the cosine of theta, that ratio is x over r. So that's going to be 7 over the square root of 58. And we need to rationalize that denominator. So square root of 58 over square root of 58. So that turns out to be 7 times the square root of 58 over 58. Now let's do the sine. Sine of theta, the ratio of that is y over r. And the y is 3. So 3 over the square root of 58. And rationalize that, just like we did with the last one. So we end up with 3 times the square root of 58 over 58. Now, let's squeeze secant in up here. And let me go ahead and make a little bit more room. I like to sometimes do secant and cosecant right after I do sine and cosine. So the secant of theta, well, that's going to be r over x. It's also the reciprocal of the cosine. So what I don't want to do is take the cosine and then turn that upside down and have to rationalize the denominator again. I either want to start right here fresh from these original x and r, or start from this point and then flip it upside down. So your r is square root of 58 and your x is 7, and no rationalizing necessary. Cosecant of theta, same process. You're either going to start from the ratio, or you're going to start from right here and reciprocate. Don't start over here, because then you're just going to have to rationalize and reduce that again. So the cosecant is r over y. So that's the square root of 58 over 3. Alright, let's do tangent and make a little bit more room here. Alright. So the tangent of theta, that's going to be y over x, and y is 3 and x is 7. And before I get very far, let me just give you an error alert. Alright, so the tangent is 3 over 7. I'm going to write it again right here. The tangent is 3 over 7. So this does not mean that, let me erase this. This does not mean that the sine of theta is 3 and the cosine of theta is 7. See how people make that mistake sometimes? Because this is sine over cosine. So a lot of students say, hey, the sine is 3, the cosine is 7, and then they're totally forgetting that the sine is 3 over r and the cosine is 7 over r. So just a little error alert there, be aware of that. And let's go ahead and finish up cotangent. So cotangent, the ratio of that is x over y. So that's going to be 7 over 3. And there are your 6 trig ratios. Let's do another example and work backwards. So we're going to be given the cosecant of some angle is negative square root of 17 over 3. And we're going to be told that theta is in quadrant 3. And we want to find the other 5 ratios, trig ratios. So you know that the cosecant is r over 3. R over, y. So you know that's negative 17 over 3. So you know that r is going to be the square root of 17. R is not negative the square root of 17. The negative comes from the ratio because you know that the angle is in quadrant 3. So r is not negative. So we can say that the y is negative though. Alright. And next thing we want to do is find x, because we know r and we know y. So we need to find x, and then you can find all the rest of the ratios. So we know that x squared plus y squared equals r squared. So x squared plus negative 3 squared equals the square root of 17 squared. Notice how I put these in parentheses? So x squared plus 9 equals 17, and then you minus 9 from each side, so you get x squared equals 8. Running out of room here. X squared equals 8, square root each side. So x is plus or minus the square root of 8, and I can break that apart. Plus or minus 4 times 2. So plus or minus 2 times the square root of 2. But it's in quadrant 3. So is it plus or is it minus? Well, if it's in quadrant 3, let's sneak a little circle in here and take a look at it. Okay, so in quadrant 3, okay, so I would have to have some x over here, some y over here, that looks about right. Okay, so x and y. See, x is in the negative direction, y is in the negative direction, so I end up in quadrant 3. So therefore my x is going to be negative 2 times the square root of 2. And at this point, since you know r, and you know y, and you know x, you can find all the rest of the trig ratios. And if you're good with that, I guess you could stop right now. If you want to see that, I will work that out for you. Alright, so we can do the cosine next. So the cosine, oh, I got a new page and I don't remember what they were. So x was negative 2 times the square root of 2. R was square root of 17. Y equals negative 3. Okay, so the cosine is x over r. So that's going to be negative 2 times the square root of 2 over negative 3. And, oh no, we're just full of mistakes tonight. There we go, over r square root of 17. There we go. And now we have to rationalize that. Okay, so that turns out to be negative 2, and then 2 times 17, well that's the 34 under the radical, all over 17. Let's do sine. So the sine is equal to y over r, so that's going to be negative 3 over the square root of 17. Rationalize that one out. So we end up with negative 3 times the square root of 17 all over 17. And we already knew cosecant, so we don't need that one. So let's do secant next. So the secant, well, that's going to be r over x. And r was the square root of 17. X is negative 2 times the square root of 2. So we still have to rationalize this. Got to get rid of that square root of 2. So that's square root of 34. And I got a negative, so I'm going to move it up here so I don't forget it. Alright, so square root of 2 times square root of 2 is 2. 2 times 2 is 4. Okay? And then we need tangent and cotangent. Let me make a little bit of room here. So tangent and cotangent. Alright, so tangent of theta, and that's y over x. So I have negative 3 over negative 2 times the square root of 2. Negative divided by negative is a positive, so that checks out because we know tangents are positive in quadrant 3. Alright, so let's rationalize that square root of 2. So we get 3 times the square root of 2. Alright, square root of 2 times square root of 2 is 2, and 2 times 2 is 4. And now let's do cotangent. And cotangent is x over y. So my x is negative 2 times the square root of 2 over negative 3. Negative divided by a negative is a positive. So 2 times the square root of 2 all over 3. Alright, so that's the end of this example.